arrange it, right? Okay.
I don't see any bookshelves in the backdrop of anybody, any participant. Normally we see bookshelves with so many books when we join Zoom meetings. Can't take Vaga.
Now one minute more. So I will. Can I take them in now?
Yeah, it's okay, no?
Yeah, I think so.
Yeah, okay. 41. I will take them in, right?
Yep.
Now it's time. We can start for today's lecture. Yeah. Okay. Good evening to everybody. And there are people from other parts of the world. I don't know the time. Anyway, good evening to everybody and good day to others. Today we are going to have our special lecture organized by Sri Lanka ICOMOS. Today our lecturer is Max Rahrig. His topic will be new results of the Sigiriya Cloud project, 3D documentation and virtual reality presentation of the Sigiriya wall paintings. I think this would be an interesting presentation. He did another presentation for ICOMOS Sri Lanka previously also. And Dr. Max Rahrig for accepting our invitation today, joining with us to deliver this lecture. So I will welcome everybody on board. There are about 50 numbers, so all are welcome. So I will invite Dr. Nilan Kure, Joint Secretary of ICOMOS Sri Lanka, to introduce Max for the audience. Dr. Nilan, the floor is yours.
Thank you, Jayati sir. Thank you. It is my pleasure to introduce Dr. Max Rahrig. Max Rahrig studied archaeology, preservation science, and building archaeology at University of Bamberg in Germany. In 2014, he founded Format 4+, an office for the digital documentation of cultural heritage, which he led as the managing director until mid-2016. Also in 2014, he became a research associate in the chair of preservation science at University of Bamberg, where he was responsible for high-resolution 3D and non-destructive testing methods. Since 2015, Max has been working in research projects to train Sri Lankan archaeologists and conservators in the use of modern documentation methods and assisting in the research and documentation of Sri Lanka's cultural heritage sites, such as Sri Dalada Malikawa in Kandy and the ancient wall paintings of Sigiriya. In 2020, Max successfully completed his doctoral study on the topic of imaging techniques as non-destructive testing methods in heritage science. So let me warmly welcome Dr. Max Rahrig again. And Max, floor is yours, please.
Thank you very much, Milan. It's a pleasure being here today. I will start sharing my screen that you can see the presentation properly. Okay, so I hope you can see the presentation right now. It's a pleasure being here or being invited to give the second presentation about the Sigiriya project. It is a combined research project funded by the Gerda Henkel Foundation in Germany, and the research partners are the University of Bamberg, where I'm located, the Department of Archaeology of Sri Lanka, the Central Cultural Fund, and the University of Kelaniya. So let's start with a brief history of the Sigiriya paintings. I guess most of the Sri Lankan audience is quite familiar with the site, but there are also some participants from Germany and other parts. So maybe to give them also a short overview about the site, I will start here. The site or the Sigiriya paintings were created at the end of the 5th century under the region of King Kashipa, and it was a monumental wall painting which covered nearly the entire rock facade, the western facade of the Sigiriya rock. And on top of the rock was the former palace of the king, and at this area highlighted in orange, there was this huge wall painting of a size from over 140 meter long and 40 meter height. It is the earliest surviving examples of Sri Lankan school of classical realism. And until today, only a small area of around 25 to 4 meters survived. This is located here in the area called Fresco Pocket A and B. And there are some other areas, the fresco pockets C, D, and E located in these parts, where also some fragments of paintings are survived till today. The studies of the paintings started or begin in 1894, and it was so it was the beginning of a history of studying and conservation of the wall paintings. Around 1894, the access to the painting was quite difficult, like you can see in the image down here. So a first spiral staircase were constructed around 1905 to provide a better and much more safer access to the site. These stairs are still on site and giving still the access to the paintings today. Also around 1900, the first conservation campaign started. It was mostly hole filling and retouch. And in 1943, the first conservation treatments by the use of polyvinyl acetate, polyvinyl PVA, was conducted on site, also to give to consolidate the paintings to get fixed again to the rock surface. And 1967-68, there were restoration campaigns due to vandalism on site, and around the early 70s, some reconstruction of lost areas and the consolidation with acrylic resin paraloid B72 were carried out. Around 1978, the area was covered, or the paintings were covered by curtains in front of the visitor platform to protect the paintings against sunlight. And around 1982, the entire site were declared as a UNESCO World Heritage Site. Let's have a look at the condition of the paintings by today. So the first overview is overwhelming. The depiction of around 22 so-called apsaras has survived until today, and in the overview it looks in a very good condition. But if we have a closer observation of the paintings, we also see some problems. So, for example, color degradation and whitening of the paintings, like you can see here, as well as pinkish alterations in these areas where also some parts of the paintings are fading and are not visible so good anymore. And we have problems of vandalism, people scratching graffitis into the plaster. It is a very narrow area to explore the paintings on site, so it is quite easy for people to get to touch the surfaces also. And we have some problems due to the former restoration campaigns. So we have glossy stains of the resin of the paraloid, and also dark granules related to the use of PVA. So we had several project aims for our research project, which started in 2018. These project aims based on recommendations of Werner Schmidt, who is a consultant of ICROM, and he was in a site observation for UNESCO on site at Sigiriya in 2016 with several colleagues from Department of Archaeology and the Central Cultural Fund. In the project, we wanted to carry out initial documentation by the use of 3D scanning and photogrammetry to provide a permanent record and a basis for damage and condition mapping and the monitoring of ongoing decay. Additional to this 3D documentation, we also want to carry out surface observation by the use of non-destructive imaging techniques, which is multispectral imaging, ultraviolet, visible light, and infrared photography, mainly. We have to take microsample analysis for the detection of historical materials, painting techniques, decay products, and to understand the materials applied during former treatments to get an idea what materials are located on site and how they react to each other, and how we can handle them for a proper restoration measure in the future. And all these tasks are part of a program for capacity building and the transfer of knowledge to Sri Lankan archaeologists and conservators through on-site training on all the technologies we used. So the project is separated in two project campaigns. The first one was running from October to November 2018, where we conducted a high-resolution documentation of the paintings and a detailed documentation by the use of raking light imaging. The second campaign, I will come to it later in more in detail, is still pending. We are now, due to the pandemic, in quite delay. So we hope to carry this second campaign out in as soon the pandemic calmed down, and then we want to carry out the documentation of the entire painted area. So although the inaccessible areas of the rock by using 3D laser scanning, drone observation, and there we also want to carry out the multispectral imaging and the damage and condition mapping and the microsamples. But let me talk about this later. Let's have a look on the first campaign and its output. So here you see some impressions on site from November 2018, where we used this structured light scanner. It is a high-resolution scanning technique for to document the surface in a very high accuracy. And it was used also in the huge team of Sri Lankan specialists from archaeology and wall painting conservation, and 3 colleagues from Bamberg, David Höpfner, and Katrin Phil, and I were showing the archaeologists and conservators how to handle such techniques. Let me give some technical background for structured light scanning. It is a non-destructive and non-contact documentation technique based on light projection. So this is an example how such a machine can look like. Some schematic impression how it works. We have a projector. This is giving light, ordinary LED light, with a structure, you see it here, of white and black patterns onto the surface, and a camera will capture this pattern of light on the surface and is able to measure or to calculate 3D points at the borders of these lines. So we don't have to touch the surface, and it is absolutely harmless, this technology, for the historical paintings. A single scan can just capture an area of around 60 by 60 centimeters. So we need to have a lot of single scans to capture the entire painted or the entire wall paintings. And by doing this, we have to have at least 50% overlap between the single scans to align them properly, to give an orientation from one scan to another. And step by step, we took, for example, here, this is the result of one day where we took around 80 scans in the night. And at the end of our first campaign, we had 750 single scans to capture the entire formally painted or the entire painted area. And so of a size of around 25 meter and a height of around 4 meter. This is now the result of these scans calculated or processed after the first campaign in the 3D laboratory of Bamberg University. And here you see the surface model. This is a so-called 3D surface model of the fresco pocket A and B. And as you see here in this result, it is this area. The resolution of this surface is pretty good. So we have amount of a detail accuracy of 0.3 millimeter, where you see all damages in the surface and also, for example, plaster addings and cracks directly in the topography of this 3D model. But we want to have a documentation of paintings, so we also need an image information, photorealistic texture of this. So in the second step, we captured a lot of single images to provide color information to the 3D model. So this is the team of for capturing the images, and they used LED spotlights to give a very accurate and very smooth lighting to the surface, and we captured all the entire area of fresco pocket A and B by a lot of images. They are color corrected, so we provided a true color information. At the end, we took around 3,000 single images to get the information, the surface information of the entire area. So, and the next step is to combine the images onto the 3D surface model. And we did this by technology called photogrammetry or image-based modeling. The first step here is to combine the images or to align the images to each other. The software will detect automatically similar points between the images, for example, the ear, the eye of this apsara, or parts of the fingers, and will combine two images to each other, then a third image, and though ongoing till all these 3,000 images were aligned to each other. And the next step is to align the images also to the 3D surface model. This we can do also by giving information where, for example, such details like this plaster border is located in the 3D model. And in the end, or the next step is that we have the orientation of the images, which you can see here, all these blue parts here with some impression of the single images. So all these images are located to the 3D surface model. We have this orientation, and now we can calculate the texture onto the 3D model, which you can see here in an overview, or here as a first impression of the 3D model. Let me give you a better overview about this, the entire 3D model, so that you can see all its details and of the model. So we will start here in this corner where we get some impressions of the paintings, and the accuracy is pretty good. So we also see, for example, injection holes. You can see over here. We see areas, problematically areas of these glossy stains on the surface, and yeah, here you see it again. Parts where cracks were filled by PVA or paraloid, and we have this problematic glossiness on the surface. We have a proper documentation of the actual condition of the paintings, and we see, for example, also the parts of underdrawings. So here you see an area, another hand where the artist first want to show a hand of this apsara, but later by adding the color, he decided not showing this this hand anymore. And yeah, I will give you the opportunity to enjoy this this for a second. In this area, we also have some graffiti, which are over here in this area, and the image detail is high enough to see this also. And for example, in this area, we see traces of the brushes while applying or smoothing the plaster and applying the painting. Okay, so this is the 3D model with texture information of the Sigiriya paintings, and this will form the basis for the next steps. And I will give you a short overview what comes next. As soon the pandemic calmed down and we are allowed and able to travel again, we want to carry out this second campaign. And one thing we want to do there is the documentation of the entire formally painted area by drone and 3D laser scanning. We carried out 3D laser scanning in 2015 at Sri Dalada Maligawa in Kandy. You can see it over here. This is a laser scanner. It is again a non-destructive and non-contact documentation technique. The laser works in the wavelengths of 950 nanometers. Here you see the electromagnetic spectrum. The visible light, so the light we can see by the human eye, runs from 400 nanometers to 700 nanometers. Before that, we have the ultraviolet light, and after it, we have infrared. And in the infrared, at the very beginning of the infrared, we have these 950 nanometers where this laser scanner is working. It is harmless for historical objects and also for people, so it is not a problem for the eyes, for example. Such a laser scanner is working on a tripod, turns around 360 degrees, and is measuring single points with 3D coordinates, and provides in the end a so-called 3D point cloud. You can see it here, for example, for the shrine at Kandy, and an overview of the entire site we captured in 2015, and that we want to use to create a 3D information of the entire western rock facade, and combine this in the next step with images from drone observation. So flying with a drone to get access and high resolution images, for example, at these inaccessible fresco pockets located here, here, and here, and also the other areas which are not accessible in these days. We want to observe and map on the 3D model in the next campaign to locate, for example, relics or plaster fragments at these areas. Additional to that, we want to carry out the multispectral imaging by the use of ultraviolet, visible light, near infrared, and mid-range infrared thermography. These are also non-destructive and non-contact documentation techniques. Just for the overview, you saw already the electromagnetic spectrum over here. And by using these imaging techniques, we have different, we get different information about the surface. For example, this VIS, visible light imaging, it is the normal photography. You can also carry out with your mobile, but of course we will do it with proper camera equipment. So by carrying out such documentation, you will get information about the main color of the paintings. By using ultraviolet light, we get more information about varnish and retouch on the surface. So it won't penetrate that deep into the surface. And with the infrared, where we have a bit longer wavelengths than, for example, in the UV and in the VIS, we are able to look underneath the main color to reveal also, for example, underdrawings. And there's another technique, this mid-range infrared. So this is located in the area of 2,000, I guess 2,400 to 5,000 nanometer. range, where we will carry out an active infrared thermography. This will work in a way in a combination with halogen spotlights. So these are just ordinary halogen lamps, like used, for example, at the Dambulla caves to provide light inside the dark caves. So very simple lights, but they provide a lot of infrared radiation. And by using these lamps and the exposure to the surface, to the paintings, the infrared part will penetrate into the surface and get reflected. And so we will heat up the paintings just a little bit, for example, 1 or 2 degrees Celsius, and we will monitor the heating and the cooling down phase of the paintings, and that may help to reveal also underdrawings which are deeper in the paintings or covered by some plaster. And we also may detect areas where the plaster and the paintings get detached from the rock and may collapse in, or there may be the threat that this area may collapse. And to detect this, we want to use the mid-range infrared thermography. Additional to this, there is planned to carry out the transfer of damage and condition mapping on the 3D images. So in 2016, the CCF carried out a very high resolution or very high quality damage mapping of the Sigiriya paintings, like you can see, for example, here, where areas of retouch are mapped, and we have information of injection holes and damaged areas. And this is done in an analog way by hand drawing, but the digital technologies allow us to carry out nowadays this mapping also on images or on the 3D files. So we want to create CAD plans, rectified images of the paintings, and then we want to map this information onto the image information to give a better orientation. This will be done by a wall painting conservator from University of Bamberg in close cooperation with the conservators from CCF and DOA. And it will also serve as a site monitoring to see changes between 2016 and hopefully 2021 when we carry out the next campaign. The result may look like this, for example. The rectified images of the 3D model will serve as a basis, and on that we will map all the information. For example, like here, this border of plaster, and or some areas where cracks are running, and the areas where plaster repaired are located, and such information we will map directly on the images coming from this 3D model. And all these things will provide image information, and will be the documentation part. But we also have to understand the damages and the paintings to develop an idea or develop proper conservation measures in future. So for this, we need to take microsamples for analysis for the detection of historical materials, painting techniques, decay products, and the materials applied during former treatments to get an understanding how all these things interact to each other, and So just a short impression. So the microsamples, we really need very, very tiny pieces of the paintings and plaster. Like you see in this image, here we have a scale of 50 micrometers. So this is the diameter of a human hair. So the entire sample is very small, but we get information about the plaster and the primer of the painting, and of course of the paint layers. And we also can move these samples into ZEM-EDX, for example, to get a mapping of elements, to understand what pigments were used for the paintings, and what ingredients were used for the plaster and for other layers. And we are able to give also analysis of the binding materials by other analytical methods provided by the laboratory of Bamberg University. And so we may get a very bright overview about all these historical materials and the later materials applied to the paintings. So, but these are all steps which have to come in the next campaign as soon we are allowed to start there. But meanwhile, we had plenty of time, and using the 3D model, or such a 3D model, is also a good basis for other users. And I want to show you now a VR presentation. It was carried out in cooperation with the Deakin University in Australia. I was able to spend some weeks over there during a DAAD fellowship at the Cadet Virtual Reality Laboratory. And I created the first VR presentation of the Sigiriya paintings to show you the potential of such a virtual or online presentation, where it's also possible to annotate directly information linked to the paintings, and that would be a suitable method to allow people to explore the paintings in times when we are not allowed to access to the site, for example, during the coronavirus pandemic, or even for people who are not able to climb up these stairs to the site, people in wheelchairs or elder people who are not in a good condition anymore to climb up there. And now I will switch over to the VR presentation to give you the live view. I hope you can see it. So this is just the first draft of such an VR presentation. You may already know these fancy VR goggles you can put on your in front of your eyes to explore a site, or you can do it with your mobile phone, or as I'm doing it right now, we can explore the site on my PC. And yeah, right now I can walk in this 3D engine to have a impression of the entire site, and I'm able to really explore and have a detailed look onto the surface by myself at every spot where I want to go. And you see here already the accuracy of the or the high detail of the texture information. So the 3D model is very high detailed, and in this way we can also link information to guide the visitor in a better way. For example, we could implement such terminals where you can have a kind of interaction. You can give such pop-ups to give a brief history of the paintings, and or you can show some historical images of the site directly in next to the paintings, and you also have a bit more space to explore the entire site than you have in reality in front of the paintings, because this the visitor platform is so narrow. And here are some points of interest, like you see this small blue camera. Here's also an interaction possible. You see this Apsara in this red brownish color, and on the right to it there is a greenish cloud. Historical images from around shortly after 1900 showed behind this greenish cloud also fragments or parts of the of another Apsara, of another figural painting here, which is faded during the last 100 years. So today we can't see it really properly anymore, but in this historical image we get an idea how it looks at least 120 years before today. And I also want to show you this point where the paintings get damaged, and these two Apsaras lost their faces during an act of vandalism. But we also have historical images here. So
excuse me, Max, we cannot see the video. Max, we cannot see the video.
you can't see it?
No, we are still seeing
my
the
goodness.
still of the cave.
Okay, good to know. I want to try it again. Wait a second, this is, I'm sorry, I thought you see it already. How is it now?
But we can see it.
Now working, yes. Okay.
Now it is working, okay. Oh,
Yeah,
I'm
it's good
sorry, I
enough.
really thought you see it already.
Let's go to beginning of the video.
Okay. Yeah, I will start here again. So, oh my God, I'm really sorry about it. It was my fault. Okay. Anyway, so here you have this VR experience of the fresco pocket A and B, and as I move my mouse here, I'm moving the camera, and I can walk here to explore the entire site. And over here, for example, you see such a information desk where we have an interaction. This is the area where, for example, the history of the Sigiriya paintings may come up to give information to the visitor about the paintings. We have the opportunity to show historical images, like here. This is just the information desk with some historical images directly linked to the paintings. We have this possibility to have a brighter overview of these fresco pockets and of all the paintings. So we have much more space to walk around here, which is quite nice. And so here we see this small blue camera. This is a point of interest where we have interaction directly linked to the paintings. You see these red and brownish Apsara, and to the right there's the greenish cloud. And I can start the interaction now, and such historical image popped up, and it was captured around 1900. And during this time, we had there was another Apsara directly behind this greenish cloud visible. And during the last 120 years, it faded. The colors faded, and we can't see it anymore really properly. But we get an idea with this link to the historical images, for example. Of course, we can explore the paintings really good, and everywhere we want to have a close look to it. I may go over here for example, where we see all these huge details of the 3D model, and yeah, it is. You can decide where to go and where to have a closer look at the paintings. And over here, we have an area where the two Apsaras lost their faces due to vandalism, and these areas of the paintings are just covered by the whole is covered by plaster to have a smooth surface over there. But we have the historical image providing an impression how these two Apsaras looked before this destruction. And so such a VR presentation also may provide information how these areas looked before. And yeah, it is, as I told you, just a first impression or a draft. So in the future, it would be good to develop more info, or to link more information into this VR presentation, and it should be in a closer cooperation to the DOA and the CCF. For example, also to write down the history we want to deliver to the visitors here. I guess there are much more specialists in Sri Lanka than I could do. So yeah, it is still a lot to do, but I guess the possibility of using such 3D models is shown pretty well. Now I will try to switch back to the presentation. And yeah, okay. I guess this was yeah, my overview about the Sigiriya project, and I hope you enjoyed my presentation, and I'm really looking forward to continue the project. Here at this image, you see a part of our project team, and they really helped a lot to capture all the data, and also to process the data directly during the time of the first campaign. And I'm looking forward to meet up with all of them as soon as possible. And yeah, I'm really thankful for your attention, and I'm open for questions now. So thank you.
Thank you, Max, for your interesting presentation with more information and detail. I would like to invite Professor Nandadeva, our Vice President, to handle the Q&A session. And the audience can type your questions, or either you can unmute your microphones and raise your questions. Professor Nandadeva, please commence.
Yeah, okay. All right, good evening, everybody. Thank you, Mr. Jayati, sir, for allowing me to take questions. So, as Mr. Jayati sir requested, you may either type your questions to chat box. If you do so, then I will take one by one and present them to the speaker. Or if not, you yourself can unmute your microphone and raise the questions. So to start this session, I would like to ask Max. Thank you very much, Max, for doing this lecture today. And I'm sure there may be a lot of questions that may come later. What prospects you think that we may have for other sites like Dambulla? Because the Dambulla document in Dambulla poses so much challenges due to the undulation of the rock face. Therefore, documenting with other two-dimensional methods is not going to serve much purpose, though. Therefore, I believe that the 3D laser documentation will have a lot of opportunities. So, what do you have anything to say about it?
Yeah, for Dambulla, we were also in a close contact with Ajit Veyasundara, and we explored the site. At Dambulla, we have the problem that this water is dripping through the rock and is causing damage to the paintings. And also there, these technologies of thermography, infrared thermography, may be really helpful to detect the areas of very hard threat, to reveal areas or to detect areas where the painting starts losing its contact from the rock and may start collapsing. And by carrying out the thermography, we may detect these areas. And of course, we could 3D documentation is a very good technology to give the documentation of the actual condition, because same as at the Sigiriya paintings, we have this strong organic structure of the rock. So it is not just a flat wall where the paintings are applied. It is a very organic structure, and it is hard to measure and to capture such thing in a single image or in a drawing, for example. So 3D may be a very good technique for it.
Thank you very much, Max. Ashley has a question. Ashley, please unmute your microphone and ask a question.
Max, can you hear me?
Yeah, very good.
Okay,
nice to
thank you. Thank you very much for your very interesting presentation. I've just got a few basic things. Now, in your presentation, the stonework, which you had collected very carefully, comes out very strong compared to the paintings. Now, is there any way you can reduce that so it doesn't come out so strong? That's one question. The second one is this copying of the photographs and so on using the sort of various sort of methods of, say, for example, what do you say? The sort of various instruments that you use, would it have a long-term effect on the paintings in any way? And my third question is, I noticed that there are old photographs of the of what the paintings really were. Is it possible to introduce that into your presentation somewhere so that you have a holistic picture of what it all was like, rather than separate, some figures without a face and so on and so forth? Whether it's possible to interpolate the older pictures into the new, so that we have at some stage, some of us who have never seen the earliest ones can see what it really was, I was just wondering whether that is possible.
Yeah, thank you for this interesting questions. Yeah, I guess a very important question is the long-term effect of the technologies to the images. There is absolutely no long-term effect to the historical surface. These technologies are non-destructive, so they don't cause any harm to the surface. The laser beam and also the radiation of light is in an area which is also provided by daylight and very close to the human eye, and it is used at several other World Heritage sites across the world, and they are typical so-called non-destructive testing methods for the documentation. So that you don't need any worry that that it could harm the paintings. The combination to the with the historical images is a very interesting question. Of course, it is possible. I showed you in the VR presentation that we can link the images next to the paintings, but we also could use these images to map them directly onto the 3D surface, or we could put them in a CAD plan to overlay such images, to overlay the historical images on the actual condition, and then we could change between the layers to see what kind of differences are visible here. And also in the National Museum in Colombo, there are these fantastic oil paintings on canvas from the first observation of the Sigiriya paintings from 1896, and they are in such a fantastic quality drawn that we are also able to map them onto the 3D model or compare them to the 3D model, and to get information about the decay between around 1900 and today. So it is very good to monitor possible problems or damages. And yeah, your first question was
in your presentation, the stone stratification in the stone was coming out very strong. Is it possible to reduce it so it doesn't come out so strong? It was actually competing with the paintings. You know what I mean?
Yeah.
What I mean is using a more backward color.
Yeah.
Of course, it is possible. We could reduce the color over there a bit. We decided to do it not for the moment to give the actual color information or a true color information of the entire site, but it is possible to reduce, for example, the contrast of the stone a bit, and to reduce these parts.
Because it's not so noticeable when you up there. That stratification is not so noticeable, you know, because the paintings come out quite strong.
Yeah.
That's something that was interesting. And on my last question, if I can stretch it a little more, I was just wondering whether, now you referred to the canvases at the museum and so on, whether it's possible to do one completely holistic picture of what it was at the turn of the century or something, you know, so that you for anybody who wants to see it can actually see what it was, not what it is now, but what it really was, you know. I think that would be a very important aspect. If it's, I'm sure it's possible, you know, to see how that can be interpolated into what you're doing. I think the work is very exciting and so on, has a lot of potential. Whether that will give anybody seeing it a holistic picture of what this was all about, you know, and so on, rather than seeing little bits cut off, little bits damaged, little bits, and so on and so forth. Because what you've done is a documentation, right? So what I'm trying to say, so what I'm trying to say is that extending that further to a holistic image of what it was all about, and I'm sure everybody would be interested in seeing that. Thank you very much, Max.
You're absolutely right, Ashley. It is possible. We have now this basis documentation, and as you already mentioned, right, we carried out the documentation. We decided not to carry out any reconstructions, but of course, if it is wanted, it would be possible to use all the sources of historical images and explanations to create a kind of reconstruction. But this is another question for a research. But we can do it, sure.
Okay, thank you very much, Ashley, for your very enlightening question, and thanks, Max. We have in the chat box one more question from Ravini Vimala Surya. She asks us, what is the photogrammetry software you used in this project? And may I know the size of the 3D model you showed us?
Okay, yeah, it is interesting, absolutely. We used the software called Metashape, developed by Agisoft, and there are already several software for such photogrammetry solutions available. For example, you can also use Capturing Reality, and there are some open source software called Micmac and one or two other available. But yeah, we used Metashape from Agisoft. It is possible to use or to calculate also the 3D surface information with this software. We decided to use a scanning technology, an active measurement technique, to make sure that we really have this high accuracy we want to have at the site. But it would be also possible to create the 3D information out of the images by such software. The model is, for the VR presentation, we reduced it quite a lot. It is just 1.3 gigabyte. The real high surface model is around 10 gigabyte for the surface information, and all the images together are, I guess, 200 gigabyte picture information, but is reduced to calculate the texture. Yeah, so for handling, 1.3 gigabyte for the moment.
Rumini, you got your answer? Okay, you say thank you. Okay, thank you very much, Max. I do not see any more questions on the chat box, but since we have a little bit more time left, Max, I would like to have my second question. That is, remember we did a test scanning on the mirror wall, but I would like if you would be willing to explain a little bit more about the prospects we may have in using the same technique to document the mirror wall, the graffiti.
Yeah, sure. The mirror wall is the second important part directly at Sigiriya, where we have this wall of around 160 meter and maybe 3-4 meter high, covered with the graffitis from the 6th up to the 13th century, containing the earliest Sinhalese inscriptions. And we carried out testing scans over there to see if we can use the 3D scanning to reveal the graffitis better, because today the surface is in a dark brownish reddish condition, and it is hard to see these graffitis. By this 3D surface, we can switch off the texture information, like you saw in the presentation, where we just saw this gray surface of the fresco pocket. And with such a technique, we may get a better view of this graffiti to read them better. And in combination with the images, we also may have a proper monitoring of the of algae and fungi and other problematically threats to to the graffiti, but it will be challenging to carry it out for the entire 160 meter, which is really a lot when we took single scans by 60 by 60 centimeters. So I guess for this, the technology called reflective transformation imaging, it is also suitable because we have a flat surface. It is a very flat wall, and reflecting transformation imaging is also a method where you have a digital camera and an ordinary flashlight, and you move the flashlight around around the object in very different angles to create a so-called normal map, where you get the information in which direction the surface is located. It is a kind of not really 3D model, but it is a kind of 3D.
Okay.
And this would be a proper technique for the mirror wall.
Okay, thank you, Max. We have another question that came to the chat box. Shireen asks, how would this documentation be displayed? Would it be only at the museum? I don't think the actual site should be used to display information in 3D, but leave it in its present condition. Your thoughts, please. Good question.
Yeah, it is an absolutely good question. It is a question for the Department of Archaeology and the CCF, I guess, to decide what to do. But yeah, we are able to, for example, you could install a computer terminal in the museum at the Sigiriya site to give this virtual reality presentation over there, or you can provide these VR goggles for the visitors. But if it is wanted, you also could put it online at the website of the of Sigiriya to give a free access over there. But these are also political decisions which I don't have to make. This is the decision of the Department of Archaeology, but it would be possible. And yeah, using this 3D model, it might be also a way to provide a kind of presentation at touristic fairs to show interested people the cultural heritage sites of Sri Lanka, or at least the Sigiriya paintings, to hire the tourism maybe after the pandemic calmed down, to also create a kind of economical stabilization, which is, I guess, pretty needed at Sri Lanka after 1 year without any touristic.
That's correct. Yeah. Yes. Yeah. Thank you, Max. Now we have another question from Cyril. Cyril asks, could you use similar technique on other historical areas?
Sure. Yeah, definitely it would be possible. We carried out this 3D laser scanning technique in 2015 at Sri Dalada Maligawa in Kandy. There, it was not the project question to have a documentation in such a high accuracy like for the wall paintings in Sigiriya needed. It was more to create architectural drawings of the entire site of Kandy, of the temple in Kandy. But sure, it might be possible at Dambula or Polonaruva, and also at smaller sites. But therefore, from my point of view, I would more focus on the training of Sri Lankan archaeologists and conservators in handling this technique. And if they are fit to carry out such projects by themselves, it is possible to carry out proper documentation at several sites in a very shorter time than when it's just in
yeah, thanks, Max. That's a great idea. Actually, we had this idea of training a Sri Lankan team at Sigiriya project as well. And we had only, we spent only 1 month, but during that time you were able to train 14 Sri Lankans, young Sri Lankans from both archaeology department and the CCF. And after another 1 or 2 campaigns, I'm sure the Sri Lankan team will be in a position to do it by their own. And I'm sure, I remember you told us several times that you found it's much easier to train Sri Lankans than training your German students. So we are really look forward to that. And then we have another actually not question. Ashley again asked, may I make a suggestion? Ashley, yes, please. Ashley?
Yes, thank you, Nandadeva. This is a suggestion I made some time ago, but it never got carried. One thing is to see how we can protect the paintings for the future, because one of the problems with visitation and so on, we have a huge amount of problems that come up with that. And today there are lots of other people who cannot climb so high to go and see the paintings. So I made a suggestion that we make an artificial cave at a lower level in the jungle, so that like at Lascaux, right, where people would go in, see this and go off and leave the paintings only for experts who want to examine it, not for everybody who wants to go up, because that's why I asked you that question, whether it's possible to interpolate some of the earlier work into your work, so that we can then produce a complete Sigiriya fresco or whatever it is in this cave, so that the average person who goes to Sigiriya is really not interested in the paintings. They go because somebody said there's a painting and they go and go up and have a look. But maybe a lot more people will go into this cave. Now Lascaux has found that more people go into the artificial cave than into the real one, and the real one is only open to specialists, So this is a suggestion I would like to carry further, because it was made maybe about 10 years ago, so that and your technique comes in beautifully into that, where it's possible to do this artificial thing, and a lot of people will then go and see that and be very happy that they saw the frescoes, and they don't need to climb up so high and get tired and so on at the end of it. And I'm sure a lot of tourists will use that rather than climbing to the top, So just this is something that I had worked on some time ago, and I thought I'll expose it because your technique lends itself perfectly to what I was trying to suggest, Thank you, Max.
You're absolutely right. It would be possible to use, for example, this 3D surface information for different kind of 3D printing or miling, robot miling, to produce the shape of the fresco pockets, or to create such real copy on site. And sure, if it's wanted to create a visitor center, maybe down at the close to the rock, to have some similar presentation like the Lascaux caves, this documentation may provide a basis for it. Yeah.
Okay, thanks, Max. We have 2 more questions. One from Shalanga, second one from Kusum Siri Kodituaku. I'll take Shalanga's one first. Shalanga asks, is there a way to 3D model underground ruins? If so, to what depth? Is this a question?
It's very interesting. Absolutely. I'm coming from the field of archaeology, so the work of excavation and revealing structure covered by earth was also a part of my studies and former works. There are technologies called, for example, ground penetration radar, where you can locate structures under the earth, for example, where walls or ruins of walls are located, and such things. You don't get so high accurate 3D information, but you get an impression where such areas were located. By the technologies we used so far, it is not possible. The scanning is just, with 3D scanning, you just capture things you also could see by human eye. So you can't look through the surface, and so yeah, but with other geomagnetic or geophysical prospection technologies, you may at least get an idea where such underground ruins are located.
Okay, thank you, Max. I hope Charanga got the answer. We have the second question is comes from Kusumchiri's the mail address, but the person who is asking the question is Menaka, who was in our team. Menaka wants to know, Max, are we going to introduce any conservation program after this scanning and interpretation?
Exactly. And hi, Menaka, it's nice to know that you're here and listening. I'm looking forward to see you also in the next campaign. And we decided to, or we had to separate the aims of the project into two different campaigns, because the 3D documentation is one thing. It needs a lot of processing of the data after we came back to Germany to produce this 3D model, but it is just the basis. So the main idea of our project was not just this 3D model for presentation purposes. This is just a side product, let's say. So in the combination with the multispectral imaging, where we get, by the use of ultraviolet and infrared photography, we get more non-contact information of the paintings directly on site. We will get better understanding of the technologies the artist used at shortly before 500 to draw these paintings. And of course, in combination with the microsample analysis, we get information about the products, pigments, and ingredients for the plaster and other things were used, and also about the former conservation treatments, so of the materials used in former conservation campaigns. And by all this combination of information, we hopefully may help to plan or to create an idea how to conserve the paintings on site.
Okay, Menaka, you got your answer to your question.
Thank you, sir. Thank you.
Okay, good to hear from you, Menaka. Yes, we have another question from Nilan. Nilan, well, it's a comment. I hope, apart from using this documentation for presentation purposes, it can be used to understand the different interventions that have been carried out over time and to understand the current deterioration process. Can you please elaborate on this a little?
Yeah, I guess this is also related to the question from Menaka right before. By not only by this, so we now just did the documentation of the actual condition, and the next step is using the data for real conservation purposes, and this needs the combination of the other imaging techniques and the microsample, and then we analyze this, and then we get more information about the deterioration and also about the technologies or the historical working techniques. And yeah, I'm really looking for this absolutely important second campaign as soon as possible.
The kind of information that we are expecting is going to come from the multispectral imaging that you're going to we are hoping to do in the next campaign. With that information, we would be able to know a lot about the painting techniques, and then to be followed by microsample analysis, we would be able to make decisions about the deterioration processes and appropriate conservation treatment methods.
Exactly. We need to know what materials were used in historical time, and we need to know what products were applied during the last, let's say, 100 years of conservation history.
Yeah.
And when we identified all these different ingredients and know how they react to each other and how they deteriorate over the past years or the past 100 years, then we may get an idea what to do to carry out to reduce these shiny areas and this darkening and such things for proper conservation and hopefully in the near future.
Okay, thank you, Nilan. Hope you got the answer to your question. And I see no more questions on the chat box. So let me thank you, Max, and thank you, everybody, those who raised questions and those who made comments. Thank you, Max, once again. And floor is to you, Mr. Jayatissa, to propose a vote of thanks.
Thank you, Professor Nandadeva. Thank you,
We cannot hear you, Ms. Jayatissa.
Is that so?
Yeah.
Me now?
Oh, okay.
Okay.
Okay. Yeah.
Okay. Thank you very much, Professor Nandadeva, for handling the Q&A session. And I would like to thank everybody who participated for the Q&A session to make it a live program. And then again, I would like to thank Max for accepting Nilan's invitation on behalf of ICOMOS Sri Lanka, and delivered the second lecture for the ICOMOS Sri Lanka. The first one is actually, he did it in Sri Lanka when he was here. And I think it is also on the web. We can, anybody would like interested, you can see, watch it. So thank you again, Max and everybody, and especially for Nilan Kure, Dr. Nilan Kure, I'm a joint secretary, for arranging this lecture. And actually, ICOMOS Sri Lanka got opportunity to have more lectures and discussions because of this pandemic situation on various subjects. So it is another, I think, a good thing we go together several times. So we are going to have another lecture also very soon. We will let you know through the web and or Facebook about the next one. Well, thank you very much for joining with us, and have a nice day, everybody, and goodbye on behalf of ICOMOS Sri Lanka.
Okay, thank you, Max. Okay, goodbye to everybody. Thanks.
Thank you. It was a great pleasure. Thank you.